what we're going to go through now are actually two pretty similar concepts called relative change, relative error, and you might also hear this as percent error. So before we begin with formulas, we're going to consider two different scenarios. Suppose in scenario one, I owe you $20, but I'm only giving you $10 back in return. Scenario two, you win $5 million in the lottery, but you end up receiving $4,999,990. So in both of these scenarios, if you consider how much money you've lost, in the first one, you got 20 but only got $10 back. You lost 10 bucks. In scenario two, you lost $10 out of your 5 million. So in each scenario, you're out 10 bucks. However, if you're trying to think about which of these is a bigger deal, you're out the same amount of money, but really in this first scenario, you're going to be a little bit more mad at that person because that's half of your money they didn't give you. Where if you're losing $10 out of 5 million, it's not as significant of a deal because 10 bucks is a measly percentage of this. So in these two scenarios, scenario one would seem like it would be a bigger deal. So although we've lost the same amount of money in each case, it's more significant in the first scenario. Okay? So that's what this idea of relative change, relative error, and percent error is going to be. You're trying to figure out how much did you lose or gain in each situation, but really what is that in comparison to the size of what you started with? Because in scenario one, half of your money is gone, but in scenario two, it is less than 1% of your money that has disappeared. So very different cases, even though it's the same money lost. So we're going to introduce just some vocab words to really mean stuff you're used to. In the case that we're losing $10 in each scenario, this is going to give us a quantity we call our change. So the change calculates the difference between two values. So I'm going to use words for this first. The change is your new value minus your original value. Okay. So the sign does make a difference on these because your change could be positive or it could be negative. So in this first scenario, you lost $10, your change is negative 10 from what you started with. But if it was the opposite, I owed you 20 bucks, but I ended up giving you 30, you've gained 10 bucks. So your change will be positive. So the way we indicate this with variables, we use X, because that's typically our variable. To indicate that it's our new value, we'll use a subscript of N. And then to indicate it's the original value, we use a subscript of O, or a 0. Okay. Now that we have the change, what I want to do is see what is this change in comparison to my original value. So what percentage of this size is this change in comparison to the original value? So this is what we call relative change. Relative is giving us this comparison. So the relative change tells you the percentage of size the change is in comparison to the original value. So again, I'm going to do this in words and then we'll go back to these subscripts. So if you want to find the relative change, you're going to take the change in your two values and you're going to divide it by your original value. And then we have a formula for the change. So this is the new value minus the original value. And then it's going to be divided by the original value. So in terms of our variables, the new value is x sub n, the original is x sub 0, or xo, and we divide that again by the original value. Okay. So you might also hear this not just called the relative change. You can call this the percentage change or the percentage increase or the percentage decrease. Because remember, when you're taking something and dividing it by its starting value or that total amount, it's finding the percentage. Okay. So with these two scenarios, let's go ahead and find both the change and relative change in each situation. So in the case I owe you $20, this is the original value. It's what we started with. That's what you gave me. The money you got back, however, is the $10. So this is our new value. So our change is going to be the new minus the original. So our new value is 10, our original is 20. And if you subtract those, that gives us -10. So again, what this sign is doing is just indicating that we lost money. Okay. If it was positive, that means we gained money. So we've got our change. Now let's find the relative change, or in this case, it would be a percentage decrease. So we're finding what percentage it went down by. So I don't need to go through the work because I already found the change in the first step. So we're going to use the idea that this is the change divided by the original value. So our change is -10. Our original value is $20. And so you have a ton of different ways that you can input this. You can reduce these fractions. So top and bottom are divisible by 10. So this is -1/2, which as a decimal is nice. It's -0.5. And then if you want to change it to a percentage, remember you just move that decimal 2 places to the right. So this is also the same as -50%, okay? Which is something that we could see. We lost half of our money, so it is -50%. Now we'll do the same thing with the second scenario. You win $5 million. So in this case, this is our original value. It's what we should have gotten back. But we only received this $4,999,990. So this is our new. So when we do the change, it's the same situation. It's going to be the new value minus the original, which is 5 million. So the exact same change, -$10. We've lost money from what we should have gotten. So all we do to find our relative change is we see what percentage is this of our original quantity. So we take the -10 and we divide it by our original amount, which is 5 million. So you can plug this into your calculator. You're going to see it is a ton of zeros. So it's 1, 2, 3, 4, 5 zeros followed by a 2. Okay. And again, it's negative because we lost money. And if you want the percentage change, all we would do is move that decimal 2 places to the right or times it by 100. So as a percentage, this is 1, 2, 3 zeros followed by a 2. Okay. So this is our percentage decrease in scenario 1, and this is our percentage decrease in scenario 2. So now you can really see why in scenario 1, it's a bigger deal that we've lost $10 because it's a much larger portion of our money. Okay. So this is really just giving you formal terminology for a lot of stuff that you're used to. So in some of these problems, it's not necessarily a formula that you have to remember. You can kind of just take it at face value too. Lots of things in the world go up because of inflation. So you think on a year-to-year basis, your percentage change could be 7 or 8% because that's what inflation currently is. So when you're thinking about working with cars, for example, we're going to do an example now where next year's model of sports car is actually going to go down a certain percentage. And we just want to figure out what's it going to go down by, and then also what's the price of the model going to be. So the next model of a sports car is going to cost 4.8% less than the current model. The current model costs $53,000. We want to figure out first, how much will the price decrease be in dollars? And again, you don't have to do this by plugging things into a formula. You can think about this in a logical manner. So the current cost is $53,000 and it's going to decrease by 4.8%. So if I want the decrease, I'm just going to figure out what is 4.8% of $53,000. Okay. But to tie this in with what we've known, this 4.8% is our relative change. So instead, we're going to go about that approach, but again, you don't need to go through this method, okay? So here, this 4.8% is giving us the relative change. And we don't want it as 4.8. We have to put that as a decimal. So as a decimal, that is 0.048, okay? The 53,000 is our starting value. So this is our original amount, okay? And if I'm looking for the price decrease, all this is asking me for is what is the car going to change by, okay? So I've got my original value, I'm searching for the change, and I have my relative change or my percentage decrease. So utilizing my formula, remember the relative change is equal to the change divided by our original value. Okay. So plugging in those pieces, our relative change is 0.048. The change is unknown. And our original value is 53,000. So we haven't quite yet talked about solving equations. But the idea is here, I want to get this change by itself. And since I'm dividing by 53,000, what I'm going to do is multiply both sides by 53,000 to get rid of it. Okay, because that will cancel each of these out. So all we're doing to find our change is we're taking 53,000 and timesing it by that 4.8%. Okay. So our change in this case, or what our decrease is going to be $2,544. Okay. So all it is 4.8% of 53,000. Now that I know this is going to be my decrease, if I want to figure out the price of the next model, I take my starting value and I'm going to decrease it by $2,544. So I'm going to take my 53,000 and I'm going to subtract what my change is. So next year's model is somehow magically going down, and the cost of it would be $50,456. If it instead was a percentage increase, then you just add it, okay? Let's try another one. The price of an item has dropped to $91 today. Yesterday, it was $140. We want to figure out what is the percentage decrease. Okay. So again, just labeling my pieces. Yesterday was the starting value, so this is the original amount. Today it's 91, so this is my new amount. So if I want that percentage decrease or that percentage change, we're just finding the relative change. So I'm going to take my new value, subtract the original, and divide it by the original. 91 minus 140 is negative $49. So the price went down $49. And we divide that by 140. And this does divide nicely. It is negative 0.35. Now, because this one does ask for percentage decrease, it makes sense to automatically switch it to a percentage. So you move that decimal 2 places to the right, which gives you 35%. Okay. So our percentage decrease is 35%. And again, that's all that minus sign is telling you. It's a decrease. So just kind of pay attention in your homework to the words that I use. It will kind of indicate whether you need to put the minus sign or whether you don't need to. You kind of just skip it, because this is specifically asking for the percentage decrease. You would just have to enter that 35%. Okay. So that's our concept of relative change or percentage change. This next concept we have is honestly very similar, just different words. The only difference that here is we're not going to care about whether something is a positive or negative quantity. So mostly these next 2 words we're going to talk about when we're estimating something. You don't care if it was an overestimate or an underestimate. You're just caring about how much you're off by. So we have this different verbiage that we end up using here. So we had percentage change, which that indicated we needed to care about whether it was a decrease or increase. Now what I want to do is talk about error, because error is how much you're off by. And again, doesn't matter about an over or underestimate in this situation. So when we talk about absolute error, that's the exact amount that we are off by. So you have an estimated value, but then there is a true or an actual value. The absolute error is just going to find what is the difference in these two. So our absolute error is we're going to take the estimated value and we're going to subtract the actual, or you can call it the true or real value. Okay. And like I said, we don't care about whether it's an over or underestimate, so I'm not going to be concerned about positive and negative signs here. So what we actually do is put these in something called absolute values. Okay. So just so if you need to look these up, the terminology for these bars is the absolute value. And all that does is it turns a negative value positive. So to kind of show you just off to the side, if you take the absolute value of -2, all it does is destroy that minus sign and give you +2. The absolute value of -7 becomes +7. If your number was already positive, it really does nothing. The absolute value of 2 is still just 2. So all that's going to happen with these bars is if it's a minus sign on the inside, it is going to destroy it to make it a positive quantity. So our absolute error and our percent error are always going to be positive amounts. Okay. Now our percentage error does exactly the same thing. We see, okay, how much were we off by, or how much did we lose or gain, just like the other one. And we're going to find what percentage that is to the real value. So here we take the absolute error and we divide it by the actual or true value. So to put all of these pieces in together as a large formula, you take the estimated value, subtract the actual, and divide it by the actual. And then we put these absolute values to guarantee that the thing we have is positive. So it is very, 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 very similar to our relative change. New minus original over original. Here, it's estimated minus actual over actual. Okay. So very, very, very similar formula. So we're just going to do a single example of this. Suppose Sam is estimating the length of his room. The actual length is 13 meters. He estimated it's 15 meters. We want to find both the absolute error and the percentage error. So comparing these two values, he estimated it's 13. He estimated it's 15 and the actual length is 13. So this is his estimated value and this is the true or the actual value. So the error is just how much was he off by. So in this case, we're going to take 15 and subtract 13, and we put it in these absolute values. 15 minus 13 is 2. And again, because this is a positive number, these absolute values do absolutely nothing. He was off by a distance of 2 meters. So for our percentage error, all we're going to do is take the amount we were off by and divide it by the true value. So he was wrong by 2 meters out of 13. So if you go ahead and divide these, and we'll round to just 3 decimals here, it's about 0.154. And again, since this one is percentage, it makes sense to put this as a percent. He was off by about 15.54% when you move that decimal 2 places to the right. Okay. So to just kind of show you, in this case, you get the same thing if it was an underestimate. So if I change this problem just slightly, and instead of saying his estimate was 15 meters, let's say it's 11 meters. Okay. So he's still off by a distance of 2 meters. The absolute error in this case would be 11 minus 13, which is the absolute value of -2. And so that absolute value just turns this to +2 instead. So still the same absolute error, which means the percentage error is the same. It is 2 divided by 13, which is about 15.4%. So the sign makes no difference here like it does for percentage change or relative change, because that we care, were we losing or gaining money. Here, because we're over or underestimating, it doesn't make a difference which side we're on.